Welcome. Today we are going to discuss a second uh, type of research method, and those are predictive research methods. And the one predictive research method that we're going to take a look at today is something called correlation studies. I think it's vitally important that AP psychology students understand exactly what correlational studies are and also understand what they are not, because too often in our media, uh, we misunderstand exactly what the results of a correlational study really mean. So what is a correlational study? A correlational study is simply one that shows a relationship between two variables. It shows the extent to which those two variables covary. In other words, when one variable goes up, does the other one go up or down in a predictable way? And in that way, correlational studies become what we call predictive studies, because if you do find a correlation between variable X and variable Y, then you know that a change in variable X would therefore make it more likely for a change in variable Y to occur. And so, for example, we know that there is a strong correlation between the amount of time spent studying for exams and the grade earned on exams. And so in that way, we can predict how well someone is going to do on average on an exam based on how many hours they spent studying. That provides us with a correlation. It lets us know that there's a relationship between those two variables. Now, correlation studies often represent their data on scatter plots that represent what we call a correlation coefficient. Correlation coefficient is simply a statistical index of the relationship between two variables. It tells you in what direction they vary and how intense their correlation is. You in no way need to know how to calculate a correlation coefficient for this class. That will be something that is saved more for your statistics class. All you need to know is that a correlation coefficient is going to range from -1, which would be a perfect negative correlation, to a +1, which is a perfect positive correlation. And all we mean by positive correlation is that the two variables vary or covary in the same direction. And all we mean by a negative correlation is that they vary in opposite directions. So for example, um, the link between time spent studying and grades is a positive correlation. If for some reason the amount of time spent studying led to a decrease in grades, that's what we would call a negative correlation, because they go in opposite directions. These correlation coefficients can be graphed on a scatter plot, and you see three examples in front of you. One example is the one to the left is a positive correlation. And you can see an increase in Y generally means an increase in X. And you can see a pattern of how those dots fall on that graph that indicates that allows you to kind of draw a line through the middle that shows you that is a positive correlation. What are those dots? Each of those dots represent a specific data point. So for example, if X was our amount of time studying and Y was our grade performance on an exam, then any specific dot would tell you two things: how long did that person spend studying on the exam, and what grade did they earn. The one two in the middle is simply a negative correlation. You'll see that an increase in X leads to a decrease in Y. And then the final one is simply no correlation. There's no pattern within those dots that would tell you to draw a line either as a positive correlation or a negative correlation. So that's how correlation studies are represented statistically. And here are some examples of potential correlations. We've already mentioned once, students who spend more time studying tend to earn higher grades. And in many ways, I'm sure that makes logical sense to us. We can think of a reason why studying will lead to higher grades. Second, and so that again is a positive correlation. People who get less sleep tend to have more body mass. Okay, so there is a negative correlation between the amount of sleep you get and body mass. The less sleep you get, you tend to have more body mass. So that link, and again, that might make sense to you for a variety of reasons. People with low self-esteem are more likely to suffer from depression. Again, a positive correlation there. An increase in, well, I guess you could think of it as a negative correlation. A decrease in self-esteem is going to lead to an increase in the likelihood of suffering from depression. And then finally, in major U.S. cities, when ice cream consumption increases, crime rates increase. Now that may leave you scratching your head. And I wanted to include this one because I wanted to use it to point out something that we should all take away from this presentation. Every one of these correlations presented here are true. All of them are very strong correlations. The first three, for most people, make some sort of logical sense. And so we accept that correlation kind of at face value. The last one, however, makes no sense to us whatsoever. And we need to talk about why it doesn't make sense. It doesn't make sense because of how most of us read correlational results. When we see students who spend more time studying tend to earn higher grades, we read that as saying students that spending more time studying leads to, causes higher grades. And it may very well be that that's the case, but a study that simply asked people how long do they study and then kept track of what they earned as their grades would do nothing to demonstrate that sort of causal link between the two. And so if you take a look at that last correlation, when ice cream consumption increases, crime rates increase. How many of you are sitting at home thinking, wow, ice cream, eating ice cream leads to a life of crime, you know, binging out on that Dairy Queen Blizzard, it's going to make me just go out and start, robbing, my neighbors, stealing their bike so I can go out and get some more DQ. Or how many of you are thinking that, all the criminals after they're done, on their escapade for that night, they're going out, woohoo, we're celebrating with some McDonald's sundaes. For most of us, I'm sure that seems very nonsensical. And so you have to be careful and understand that what's going on here is that while they correlate, one is in no way causing the other to occur. What's happening here is there's actually a third variable that covariates with both of these very nicely. When do we eat ice cream? Most of you, I assume, do not have a Christmas or New Year's tradition of eating ice cream. And that is because those are cold winter months. We don't eat ice cream then. We eat ice cream a great deal in the warmer summer months. What also just so happens that crime rates increase during the summer for a variety of reasons. And so while they co-vary very nicely, while there is definitely a correlation between ice cream consumption and crime rates, there is not a causal link. So it leads to this quote that we need to understand, and that is that correlation does not necessarily prove causation. And I apologize, I'm going to go ahead and fix this midstream here. This is my first year flipping flipping my classroom. And since I'm in midstream of recording this, I don't want to stop and redo it all. So we're going to fix that slide real quick. Next year, as I go through and do these again, we'll have that done ahead of time. And so again, correlation does not necessarily prove causation. There may be a causal link, but a correlation study doesn't tell you that. All correlation study will tell you is when people eat ice cream, there's higher rates of crime. And those variables covary. It in no way implies that one is causing the other to occur. So maybe sleep deprivation in some way causes weight gain, but there could be other factors as well. It could be simply that people who stay up late eat a lot of late night snacks. And in that way, it's not the sleep deprivation that's causing the weight gain. It is the eating while you're up that's leading to the weight gain. It could be that time spent studying leads to an increase of grades or better performance on exams. But it could just be that those who spend more time studying take school more seriously. So maybe they pay more attention in class. Maybe they're more engaged with whatever's going on in class. And that's what's really causing the correlation. And so you just need to be careful. Anytime you see these correlation studies, we're going to work with this and practice with this in class to make sure that we're all comfortable and understanding that correlation studies don't necessarily produce a causal link. They don't show us a causal link. You'd have to do other types of studies, namely experiments, in order to establish that causal link. Finally, we'd like to talk about what we call illusory correlations. And we need to hone in on that word illusory. What does illusory mean? It means that it's not real. So what we're talking about here is when people believe there's a correlation, but there's not one there at all. And illusory correlations happen typically when two distinct or dramatic events happen at the same time. And so, for example, here are some commonly believed correlations. That sugar consumption leads to hyperactivity in children. Parents say this all the time. When in fact, when conducted in controlled experiments, there doesn't seem to be a relationship between sugar consumption and hyperactivity at all. It's just something that parents believe occur. And one reason researchers submit is that maybe what's going on is that parents notice sugar consumption at events and times where kids are just naturally hyper. Halloween, birthdays, whatever it might be. And so that may be what's going on. The parents are just noticing that hyperactivity when the hyperactivity is really related to the activities rather than to the sugar consumption. I'm sure a lot of us have had grandparents that told us that, you don't want to be wet and cold because that can lead to getting sick. But all of us have taken biology, and all of us should know that getting sick is caused by bacteria and viruses. It's not caused by, running outside to check the mail with wet hair during the winter. That's not going to lead to you getting sick. And yes, I understand that long term exposure to cold temperatures can lessen your immune system response and therefore maybe make it more likely that you'll get sick. But we're just talking about just being wet and cold for a few minutes. No, it in no way is going to lead to you being sick. And then racial stereotypes, the relationships between race and athletic or intellectual ability, those are all based on illusory correlations as well. So illusory correlations are very useful in helping to explain why people believe in stereotypes, why people believe in conspiracy theories. They link these really distinctive events and try to come up with some sort of causal explanation that's just not there. And then superstitions, an athlete wears that wristband for the first time and all of a sudden gets 3 home runs in one game. And so he links those two distinctive events. Hey, I bought these really cool wristbands, and B, I hit 3 home runs. It must be the wristbands. It couldn't just be, a random stroke of luck. And so therefore a superstition emerges there. So correlational studies, again, they predict behavior. They in no way prove a causal relationship. They may imply one, but that would need to be justified and found in other types of studies, specifically experiments. And we do need to be careful about those illusory correlations that we all may harbor that lead us to believe that there is a relationship between two variables when none really exists. So that wraps it up for today. Our next flipped classroom video is going to take a look at experimental design and how experiments demonstrate causal relationships for us. Until then, good night.